ladies and gentlemen, welcome back for another round. This is Mr. Doolin. I thank you for tuning in. What we're going to do today is we're going to take a look at predicting products. So when this will apply is when we are given reactants in a particular problem, but they don't tell us what the reactants are going to form. They don't give us any information about the products, and then they're going to ask me to do something like some stoichiometry problems, limiting reactant, percent yield, whatever it is, and I'm actually going to have to figure out what the heck those products are if I'm going to be able to do anything. So how do we do that? Well, we base it on the type of reaction that we can identify based on the reactants. And that's really important for us to understand. Generally speaking, when we were doing our identifying types of reactions, we would just look at the reactants, and that was generally our clue for what kind of reaction it was. And so that becomes really important. That's an important skill that we're going to apply now in this particular situation. There's really 4 different situations that we're going to run into, all right? And so 4 different, I guess let me don't write it that way, just say 4 different reaction types that we'll need to know at this level, right? And so you definitely want to make sure that you understand there's only really 4 different kinds at this level. There's definitely more, and as our chemistry knowledge grows, we'll be able to predict more and more different kinds of reactions and what they're going to form, but for right now, this introductory level, we're only going to focus on these 4, all right? The very first one that we're going to take a look at is our acid-base reactions. Now remember, my acid-base reactions are double replacement. And if you don't know what DR means, you make sure that you need to make sure that you do notate that in your notes here. Okay, and so the example that I'll give you, I've got sodium hydroxide plus hydrochloric acid. I know it's an acid-base reaction because of the acid and the OH. So a lot of the times what they're going to do is they're going to say, well, what does it form? Well, the idea that it's a double replacement reaction becomes very important here because I understand that a double replacement reaction, the cation and anions essentially just switch partners. And so what I'm going to do is I'm going to take my metal, and I know that it's going to pair with the nonmetal in the other compound, or the anion, right? Na's positive, Cl's negative. And I'll come over here and I'll write them together. Now, I want to make sure that I balance charge so that I write this formula correctly, and since I have +1, -1, it'll just be a 1-to-1 pair. Now, the other pairing on this would actually be the H and the OH. And so in this one, I would either write it as HOH, or I could write it as H2O and show that I understand that it is water. Now, I want to key in on this because for acid-base reactions, notice we get an ionic salt formed and we get water formed, and that's a pretty common occurrence when we have these acids with our hydroxide bases, all right? And so very, very common that we'll end up with an ionic salt and water, but if you understand the double replacement side of this, you can easily just say, hey, I'm going to switch my cation with my anions, and you'd be all right. All right, the next one that we'll take a look at is also a double replacement reaction, and it's my precipitate reaction. And so again, I'm going to put DR. You probably need to notate if you don't understand that that's double replacement, all right? And so for this one, what I'll do, the example that I'll give is silver nitrate plus, let's say, NaCl again. And then we have to predict what it's going to give me. Well, again, in this particular case, I recognize here that I've just got a pair of molecules. I'm going to call this a double replacement reaction. At this point, we don't know any better, and you know I'm not going to try and trick you, right? If you have pairs of molecules on the reactant side, just switch partners with them to get their products. And so let's go ahead and take a look at what that's going to look like, right? My cation, my metal, would switch with my anion. So I'm going to do AgCl. I know this is a +1 and a -1. It just works out for me here. And then my other product, I would pair my nonmetal or my anion from the first molecule with my cation from the second one, and I'm going to write NaNO3. Well, I remember nitrate's a -1, sodium's a +1, so again, it's just a 1-to-1 pairing. I have to make sure that I look over here to balance those charges when I'm writing my product formulas, all right? And so again, these two not too difficult as long as you understand and recognize those double replacement reactions from the products, or from the reactants. All right, and so now let's look at the last two. All right, this one that what I'm going to look at is a single replacement. Now, single replacement, remember the biggest and easiest or the fastest way to recognize this is that you have a different single element on each side. Remember, and the single elements just replace each other. So the example that we'll look at is one that we've seen. We've actually seen this reaction in class, is aluminum trying to replace copper chloride. Now, it becomes important. I notice this isn't double replacement because I have a single element by itself. So what happens here is if it's a metal, it will kick out the other metal. Now, I'm going to put a star up here, and I want you to write this down. The element by itself must be more reactive than the element in the compound for the reaction to occur. And I want you to write that big. I want you to highlight that, because if you're identifying it as a single replacement reaction, you must check the reactivity series to make sure that a reaction actually happens. So in this particular case, my aluminum must be more reactive than my copper in order for this reaction to occur, and the only way I can do that is if I check the reactivity series that I will have as a reference. So I'll go ahead and tell you, in this particular case, aluminum is more reactive than copper, so I come over and I'm going to write, so messed up there, I am going to write AlCl. Well, looking at this, I know aluminum forms a +3 ion, chlorine is a -1, so I need 3 chlorides in that particular compound to balance out those charges, and then the rest of this, my copper, would just be written by itself. And again, that looks like a single replacement reaction. I have a different single element on each side. Just remember, if you're recognizing them as single replacement reaction, guys, don't forget to check the reactivity series, right? Okay, the last one that we're going to do is actually relatively simple. We've probably already got this one down by now. It is actually a hydrocarbon combustion. Now remember, a hydrocarbon is recognizable because it's a compound that contains only carbon and hydrogen. And so an example that is a very common example is methane, which is CH4. So notice this is a hydrocarbon. It's a combustion reaction because it's a reaction with O2, right? And a hydrocarbon combustion will always form the same two products. It will be carbon dioxide and water. Every time, all day long, hydrocarbon combustions form carbon dioxide and water. Now, this does not mean that every single combustion reaction forms carbon dioxide and water, just hydrocarbon combustions, okay? All right. So, and then don't forget, ladies and gentlemen, you'll notice I didn't spend time to balance these reactions, but once we write those products, of course, you will have to balance them before you proceed to do any kind of stoichiometry with them, all right? But these are the 4 most common ones that we're going to see at this particular level. Your knowledge in chemistry will grow, and you will learn how to do more product prediction, but for right now, we're just going to stick with these, all right? So if you had any questions, I hope you get those down. I'll see you in tutorials for those. Otherwise, I will see you in class.